Logarithmic differentiation is really pretty cool. We can use the idea here is we simply use property of logs to help help finding some derivatives much easier. If I needed to find dy dx of this, I could do it, but I'm going to have a 1/2 all this to the negative 1/2 times the derivative of the inside, which I'm going to have this product rule. So it can get a little bit nasty. This one actually wouldn't be too bad because the functions in here are pretty straightforward. But it could get nasty, depends on what you're actually dealing with. So the idea here is I have a product of things that I'm working with, or perhaps a product of functions raised to an exponent. So what I'm going to do is I'm going to start by saying y equals this function I take the derivative of. And then if I take the log of y, well, the log of the left-hand side equals the log of the right-hand side. And then by using properties of logs, I can say that then implies that log of y is equal to, well, this is the same thing. I'll write the whole thing out for you as log of x plus 3 times x minus 1 to the 1/2. I simply rewrote the radical as a 1/2. But you know, property of logs, I can bring that 1/2 up front. So this is equal to 1/2 times the natural log of x plus 3 times x minus 1. But that's 1/2 times the natural log of x plus 3 plus the natural log of x minus 1. Okay, well, that's kind of cool because it broke this thing up. So I'm going to rewrite it one more time. I'm going to just bring back my ln y. So I know that ln y is going to be equal to 1/2 times ln of x plus 3 plus ln of x minus 1. Now, if I take the derivative ddy, or ddx, I'm sorry, of both sides, I'm going to be using implicit differentiation here on the left because y is this implicit function of x. This is going to be equal to, on the left-hand side, y prime, because it's a function of x, over y. The right-hand side is going to be 1/2 times the derivative of ln of x plus 3 is 1 over x plus 3. The derivative of ln of x minus 1 is going to be plus 1 over x minus 1. So that means that y prime equals y times all of this. So y over 2, multiply both sides by y, times 1 over x plus 3 plus 1 over x minus 1. But y is our original function. So y prime, which is dy dx, equals our original function, the square root of x plus 3 times x minus 1 over 2, there's my 2 right there, times 1 over x plus 3 plus 1 over x minus 1. So there's the derivative of my original function, the derivative of the square root of x plus 3 times x minus 1. That's actually kind of a cool process. And it really can. It may look kind of convoluted there, but when you have something very complicated, this really can make life a lot easier.